number 26. Now look at table number 26. The support condition is number 9, 4 edge discontinuous. So our value for Ly by Lx is 1.25. Now look, 1.25 is not given in this table, but 1, 1.1, 1.2, 1.3, 1.4 these are given. So 1.25 lies between 1.2 and 1.3, that is column number 5 and 6. So values are definitely between this. So column number 4 and 5, sorry 5 and 6, column number from 5 and 6, the for 1.2 alpha x is 0.072 and for 1.3 alpha x is 0.079. So definitely for 1.25 the value of alpha x lies between 0.072 and 0.079. Now we have to interpolate this to find out the value, and for Ly, look, this is given 0.056. Now we have to interpolate. So for alpha x, we have to find out the values between 0.072 and 0.079. So as per formula of interpolation, 0.072 plus 0.079 minus 0.072 by 1.3 minus 1.2 multiplied by 1.25 minus 1.2, that is equals to 0.075. So value of alpha x is 0.075 and value of alpha y is 0.056. That is also given in the last column of table number 26. Okay. So moment in shorter direction mu x is equals to alpha x w Lx square, that is equals to 0.075 into 14.25 into 4.161 square, that is equals to 18.5 kilonewton meter. And moment in longer span mu y is equals to alpha y w Lx square, that is equals to 0.056 into 14.25 into 4.161 square, that is equals to 13.8 kilonewton meter. Now we have to find out maximum shear force, that is Vu equals to W into Ly by 2. Now we have to find out the maximum shear force value, that is Vu equals to W into Ly by 2, that is equals to 14.25 into 5.161 by 2, that is equals to 36.77 kilonewton. Now next step is minimum depth required. So from the formula of NxG, we may write mu is equals to 0.36 into xu max by d within bracket 1 minus 0.42 xu max by d bracket closed b into d square into fck. So mu, that means limiting moment. So here the limiting moment is 18.5 into 10 to the power 6 as we calculated earlier is equals to 0.36 into xu max by d is 0.48 regarding the condition. The value of xu max by d we may find out just below clause number 38, and in this question Fe is 415, that's why xu max by d is 0.48 as per IS 456 2000 within bracket 1 minus 0.42 into 0.48 bracket closed. Now b is the width, and that is 1000 into d square into fck is 20 here. So from this d required is equals to 82 mm, which is less than depth which we have considered, hence it's okay. That means the depth of the section which we provided, that is greater than required depth. That means the section is safe regarding depth consideration. So now Annex D of IS 456/2000, as per clause number D 1.2, slabs are considered as divided in each direction into middle strip and edge strips as shown in figure 25. This is figure 25. So for reinforcement arrangement, in middle portion middle strips are given, and in edge portion edge strips reinforcement are given. So as per clause, the middle strip being 3/4, that means 3/4 of the width, and each edge strip is 1/8 of the width. Look, for span LX, 3/4 of LY is middle strip and LY by 8 per edge strip, and for span LY, middle strip is 3/4 of LX and edge strip is LX by 8. So now let's go to the solution. Look, here in the calculation of design of main reinforcement, as per IS code provision which we have read just, the calculation has been done. So along shorter span, that means X direction, middle strip is width of middle strip is equals to 3/4 of LY, that is equals to 3/4 into 5.161, that is equals to 3.9 meter, and D is 161 mm. Now as per the equation of Annex G of IS 456/2000, to find out moment, ultimate moment, the formula is mu is equals to 0.87 Fy into AST into D within bracket 1 minus AST Fy over B into D into FCK. So in this equation, our known values are mu is our known value, moment, that is our known value, Fy is grade of steel, the yield strength of steel is our known value. Now AST means area of steel, so area of steel is unknown here. We have to find out area of steel from this equation into D, that is depth, that is also known value, within bracket 1 minus AST area of steel, which we have to find out is unknown value, then Fy grade of steel value is known, by B is width, D is depth, and FCK is characteristic strength of concrete. All are known values. So now we have to just put the values in equation, and from this equation we can find out the unknown value of AST. So after putting these all values, you can see here 18.5 into 10 to the power 6 is equals to 0.87 into 415 into AST into 161 within bracket 1 minus AST into 415 by 1000 into 161 into 20. From this equation we may find out the value of AST. So value of AST is equals to, as per calculation, 332.5 mm square. Okay. So now using 8 mm dia bars, that means area of cross section of one bar is pi by 4 into d square, that means pi by 4 into 8 square, d here is diameter of bar, that is equals to 50.3 mm square. So spacing will be equals to 50.3 by 332.5, that is AST, into 1000, that is equals to 151 mm, or we may use the spacing 150 mm. So as per clause, spacing should be list of 3 into depth 3d, that is 3 into 161, that is equals to 483, or 300 mm, or which we have calculated, that is 150 mm. So among these three least value is 150 mm, so spacing should be 150 mm, center to center will be provided. Now area of steel minimum is 0.12 by 100 into B into D. This is HYSD bar, that's why 0.12 value is used. That is equals to 0.12 into 1000 into 180 by 100 into 216 mm square. Now our AST provided, which amount of area of steel we have provided, that is 1000 into 50.3 by 150, that is equals to 335 mm square, which is greater than the value of AST minimum, that is 216 mm square. Hence, okay. So provide 8 mm dia bar at the rate of 150 mm center to center in the middle strip of the width 3.9 meter, right? So after the all calculation done in the drawing, we can see the middle strip, how it's distributed. Okay. Now along longer span, y direction, middle strip, width of middle strip is equals to 3/4 of Lx, that means 3 by 4 into 4.16, that is equals to 3.12 meter. Now effective depth along y direction will be D minus 161 minus 8, that is the diameter of bar, because already bar along x direction is provided. So in when y direction span is in consideration, so definitely dia of one bar through x direction which is provided definitely will be deducted. So that's why diameter of bar 8 is deducted from effective depth. Okay. So depth for y direction is 153 mm. Now mu, again same formula, same approach from NXG. Mu is equals to 0.87 Fy AST into D into 1 minus AST into Fy over B into D into FCK, bracket closed. Here also only area of steel AST value is unknown, other all values unknown. So just put the values. Mu is 13.81 into 10 to the power 6, that is equals to 0.87 into 415 into AST into 153 within bracket 1 minus AST into 415 over 1000 into 153 into 20. So all these values are known, only AST unknown, and mu is calculated earlier in this solution. So from this equation, area of steel will be 261 mm square, that is greater than AST minimum. So hence okay for design. So spacing of 8 mm dia bars in 50.3 into 1000 by 261, that is equals to 192 mm, or we may write that is equivalent to 190 mm. So in this case also definitely 190 mm will be the lesser value among the 3D and 300 mm, which is the spacing values. We have to consider the least value as earlier. So 190 mm will be the definitely least value. Therefore provide 8 mm dia bars at the rate of 190 mm center to center in the middle strip of width 3.12 meter.